Hello, everyone. First day of reInvent. I hope you're all having a lot of fun and learning a lot. My name is Karthik Krishnamurthy. I'm the Strategy and Business Development Lead for Smart Manufacturing, Supply Chain, and Sustainability at AWS. And before we bring on our wonderful customer, Northvolt, onto the stage, I would like to take a few minutes to talk about a few industry trends and challenges that we are hearing from manufacturing customers and what AWS is doing to help enable manufacturers in their transformation journey. So manufacturers recognize that they have a wealth of data, and they would like to make use of all that data to improve their production operations. Now, with advancement in key technologies, they see that data and advanced analytics are the next big enablers, and they would like to make use of that to become more data-driven and improve their operations and efficiency as well. As they plan and build a strategy to execute that, they are looking at becoming more digitally executed manufacturing, which essentially means that they are looking at critical metrics such as OEE, overall equipment effectiveness, to be one such where they are not only gathering that data to create visibility, but using that to control the production as well by optimizing at real time for bottlenecks and thresholds. Now, manufacturers also want to get to know their customers a little better, their end consumers' behavior a little better, so they can feed that back into product engineering and manufacturing, creating a flywheel, and they're able to iterate faster, so they can become more consumer-centric, and they can also maintain and gain that customer loyalty in long term. So one thing that the COVID-19 and geopolitical events have taught us, and the manufacturers are seeing that in their smart manufacturing strategy itself, is supply chain resiliency. So everything else that we spoke about as a flywheel can be really successful, but then if there is a supply chain fragility, that can put a stop on everything else. So supply chain resiliency is becoming a part of the overall smart manufacturing strategy. And then manufacturers are the leading consumers of energy. So the inclination towards using or being more sustainable and then lowering cost as an outcome and also trying to be more environmentally conscious is something that all our manufacturers are trying to do. And then environmental regulations and policies are another enablers that is pushing them towards having sustainability as part of their overall strategy itself. But then we see manufacturers using that not as a push, but rather a transformative way, an innovative way to leverage that for their advantage. As they go through in building that overall strategy itself and try to implement it, there are some of the challenges that manufacturers face. Data access. We have brownfield customers who are looking at legacy equipment installed over 20 years, 30 years, even beyond. And they're trying to integrate that with new equipments and bringing all those data silos together. As they do that, they not only want to create that access from their IT and OT systems, they also want to create a real-time access with low latency and high availability, so they can use that data transparency to control production. They want to do that. As they do that, they are looking at organizing a large amount of data together with standardized way and also across all the disparate silos. They need solutions that can address the overall aspect of organizing this large amount of data. Now they are implementing that in one plant, gaining trust on technology, evaluating the ROI, and then expanding to multiple different plants slowly. As they do that, they have to think about the scale of it. And also as they do that, they have to think about what is the secure way, the most secure way of doing it, because now we are looking at factory floor systems, IoT factory edge systems, and on-prem systems, and you are going to interact with the external environment. So how do you do that with the most secure way? IDC survey says that more data is created every hour today than an entire year in 20 years, just 20 years ago. 68% of the available data goes unused. We have a Deloitte survey that also says that manufacturers generate over 1,800 petabytes of data. 90% of that data is not used or doesn't add any value to the business. I wanted to ask you, please raise your hands if you are right now building a smart manufacturing strategy with an aim to create access to this trapped data in the factory floor to use advanced analytics for better business outcomes. That's great to know. So you are right now somewhere in this journey where you have started on your strategy. You're looking at data silos, standalone applications, and poor upstream, downstream communication as we talk about level 0, that is sensors, actuators, PLCs, all the way up to ERP. And you are looking at disparate machine communication protocols that you have to address to create that access to all the data silos. Some of our customers, the brownfield customers, they are looking at going past that challenge and have created that IT-OT convergence where they have created that flexible shop floor connectivity, and they have gone past the descriptive protocols and created that system integration. At this point, they are implementing point solutions for some specific use cases across a few plants, and that's their way of earning trust on the technology and trying to scale that across other plants. These are point solutions that will inform them of offline analytics that are not directly tied to production. The next step in that journey is to go towards a smart factory phase where the IT-OT convergence has happened and the border is gone. And there is an any-to-any communication possible across the layer that you see on the left side. And data transparency and decoupling has been achieved, and the customers are thinking about edge to hybrid model as well. At this stage, they are looking at deploying solutions at scale across their plants, leading into the enterprise level visibility as well. And this will give them an ability to not only connect the factory, but also control the factory. As you go towards the control side of it, you are leading into a software-defined factory itself. How is AWS helping in all this? AWS has the capabilities to help across the collect, store, analyze, and act phase of your overall architecture. What are those factory floor systems, the edge systems, and the smart products that we are dealing with in the factory floor itself? Operational data, historians, SCADA, MES, PLM, ERP, and whatnot. There are 3 different sets of services across factory edge, on-premise, and cloud that is helping in gathering all this data from the factory floor itself. And then we are looking at services across the collect, store, analyze, and act, where we work backwards from the use cases so we can deploy solutions that gather services across each of these blocks so you can build the right solution and scale it accordingly. These orange boxes that you see there on the top, the business functions itself, they will have hundreds of use cases that are lined up in each of those orange boxes. That calls for the right level of analytics services that are needed to address those. This may include AI, ML, Gen AI services as well. AI, ML, we have purpose-built industrial services such as lookout for equipment, lookout for vision, and many others that are coming into play in this specific area. But then analytics needs a lot of data that is stored in a secure way and organized in a proper way to scale efficiently. So that's the storage layer that we are looking at. And then there's a collect layer where we are looking at services such as IoT Sitewise that helps in the collection after the factory edge, on-premise, and cloud happens. Our greenfield customers who are builders at heart, so they are looking at this particular stack and leveraging or using all these different services in a way to build towards the factory of future. You will hear Northvolt talk about that a little bit very soon. Our brownfield customers, they have to deal with the legacy systems, so they are looking at modernization and migration along with the overall stack refreshment also. One thing that we are learning as we are working through this with multiple different customers is brownfield customers, they look at quick test and learn as a way to expand and build their strategy. So they are not interested in services that can be stitched together to build solutions, but rather they look at it from an end-to-end solution perspective. So what that means is the line of business personas, it can be a maintenance engineer, it can be a production engineer, a plant GM, or a VP of manufacturing. They are looking at AWS to come in with end-to-end solutions so that can help them address specific industry use cases. So what we have done is worked with our partners to build solutions that are using AWS services in the back end of their architecture. So customers can actually have these solutions implemented at their industrial environment with minimum customization. Those are specific use cases that have been called out under the smart manufacturing, for example. One thing to add on that would be end-to-end solution is one aspect, and line of business persona bringing them into the talk itself is one aspect. But then line of business being part of the strategy, and then IT of manufacturing transformation coming together has always been a winning strategy when it comes to smart manufacturing itself. And I'm sure many of you will agree to that. Finally, sustainability. While the regulations and sustainable operations and sustainable logistics are putting that emphasis on making that core to the smart manufacturing strategy, our customers are looking at how this can become transformational and innovative, and how can we bring sustainable products, sustainable manufacturing, sustainable supply chain into the mix. So whether it's an outcome such as ESG reporting or circular economy or even decarbonization, you look at data and go past the incompatibility and the level of standardization needed, so you're able to create that visibility to get the business outcomes. So with that, I would like to get Northvolt on the stage. Marcus from Northvolt will talk a little bit about their journey. Northvolt is an AWS customer who's at the junction of smart manufacturing and sustainability with proven success in not only collecting data, but also controlling the factory with that. With that, I would like to pass over to Marcus.
Thank you, Karthik. Now, unless you have been living under a rock for the past 10 years, which I doubt, you will have undoubtedly noticed the accelerating pace of electrification in industry, but also across society as a whole. We can see that very notably and noticeably in the sales of electric vehicles. So now, more than 10% of global light vehicle sales are fully electric. And more electrification means need for more batteries. And that's why we are here. My name is Marcus Ulmefors, and my role at Northvolt is Director of Data and Machine Learning. I'm delighted to be here with you and see a full room of interested faces. So now we're going through the story of how we scale gigafactory manufacturing of batteries. To start off, let's set the scene. Let's look at some perspective here and remind ourselves of the lithium-ion battery demand globally. We look at some historic data from 2015 and 2020, and also some industry projections for 2025 and 2030. Maybe you heard this famous saying that predictions are hard, and especially if it's about the future. But if we adjust these future numbers a little bit up or a little bit down, it doesn't change the underlying story. It couldn't be more clear. This is more than 100x increase in 15 years. So not 100%, 100x. Lithium-ion batteries have been around since the 90s in consumer electronics and devices, and we use them every day in phones and laptops. But more laptops is not the reason this chart looks like it does. We will need batteries for electric vehicles and cars, buses, trucks, ferries, boats, and even commercial aviation before the end of this decade. So this is now a race against the clock to reach these numbers. and a lot is at stake. We need to make this work in order to enable a transition to a clean energy future. Northvolt is Europe's first homegrown gigascale battery manufacturer. And our mission is to build the world's greenest battery. Our company was founded in 2016, that's 7 years ago, and today we are 5,000 happy colleagues representing 100 nationalities. The photo of the factory you see here is our first gigafactory. It's located in the city of Skellefteå, which is an 8-hour drive north of Stockholm, Sweden. The factory is named ett, which is a Swedish word for one, indicating there will be more to come. Fully built out, this factory will be able to produce enough batteries every year to power 1 million cars. So 1 million cars a year out of this factory. What you see in this photo represents around 25% of that full design capacity. The first cells were assembled in December 2021, and the first customer deliveries in the spring of 2022. So this is real today, now, and we're just getting started. So let's look at what's special here. We have the mission of building the world's greenest battery. That means that sustainability needs to be at the core of everything we do. This location is chosen very deliberately for access to 100% renewable energy that's generated in the nearby region from nature, so wind and rivers. This site is also a manifestation of vertical integration. You see on the right side here the cathode active material manufacturing, so that's the special battery chemistry that's really important for performance. You see the cell assembly also on the right, and all the way to the left you see the recycling operations. So you have a single site with multiple parts of the value chain. So this is a co-location of operations that closes the loop of circular manufacturing. We are effectively replacing a global supply chain that normally spans multiple continents with a few minutes walk. And recycling has been part of the Northvolt sustainability model from the very start. And that is why we can set this target for 2030 of new cells that are being produced to use 50% of recycled battery materials. That, combined with 100% renewable energy, means that we can set the target for 10 kilograms of carbon dioxide equivalent per kilowatt hour. What does that number mean? That's maybe a metric that not everyone is familiar with. So if we take a look at or consider the industry benchmark, what would that be? By show of hands, who thinks that would be around 20? Maybe 40, 50? It's actually 100. So this means a 90% drop in carbon footprint, or a 10x increase in effectiveness. Now, so we rest our operations at Northvolt on 3 strategic pillars. So first, renewable energy everywhere. Kind of goes without saying. For electrification to really reach its full potential, we need to make batteries sustainably, and we need to charge them with renewable energy. And then second, vertical integration. We saw that already in the photo of the site. And when we talk about battery companies, we often start to think about the battery cell manufacturing. And also within Northvolt, that is the most well-known part of what we do. And there's more to it. We talked about this active material. This is the battery chemistry that you design that really determines the performance and longevity of your final product. We also make and design our own packs. These are turnkey systems that with connectivity and power electronics, and we sell these and install them for energy storage on the grid, but also for industrial applications, for example, in mining trucks. And this, of course, is essential to electrify the mining industry, which is part of our value chain, so we care deeply about that as well. And finally, we develop the processes and build the plants for gigascale recycling. This is important because at the end of life, we have a battery pack with lots of valuable materials, especially metals. And we want to recover these, both because they're valuable, but also to reduce the pressure of mining for virgin materials. And the neat thing here is that we're talking about metals that are elements and atoms, not long fibers. And you can't degrade atoms. That's not how atoms work, right? So you can reuse these over and over again using the manufacturing technology that is modern at that time. And finally, the reason we're here today, the third pillar is digitalization. That means software and data. When we start greenfield manufacturing, we can opt to start in the cloud. We can be cloud native. So there's no migration story or challenges with moving workloads. Sometimes we get invited in manufacturing-themed talks to talk about our migration journey and give advice to colleagues, and we know nothing. We haven't done any migration. Then also, on the data side, if we have this vertical integration that's part of our business model, essentially, we can now open the door to data sharing across the links in the value chain. So we get to double, triple, and quadruple dip into the investment of the data collection. This also means that we can create more sophisticated simulations and models about our operations. And to be honest, a strategic bet on data and software is the only viable option for us. We are comparatively a new and young and a small company in this space. So we have no choice but to act faster and use more software and data. We need to scale with data and not with people. Within manufacturing, as you might know, this is a manufacturing track and you have experience within manufacturing, you will run into obstacles when you start changing stuff. And not least if you change the team working in your process, or you change the product, or you change the equipment, for example. If any of these are new, you will run into fun obstacles to deal with. If all three are new, such in our case, you will have excitement cubed. As we go through our operations, we'll uncover new information, we'll learn about how to do stuff better every day. Going from the start into the cloud and running cloud native, focusing on serverless technologies, allows us to deploy early and iterate often. This is important because speed for us is one of the major challenges. This has to happen fast. The scale of this industrial bet is immense. You might have seen on the previous slide, the cumulative customer order so far is $55 billion. So there's a lot at stake. So as we scale our physical and digital capabilities and capacity, we need to have flexibility at the core of our expansion model. So it's not an accident that when we look at our architecture and for our digital backbone, we gravitate towards serverless. And in AWS case here, we rely very heavily on DynamoDB and Kinesis data streams and Lambda, for example. And this is something we can do because we go into cloud from day one. That also means that we can spend less time on non-differentiating infrastructure and operations, and the autonomous development teams can focus on what really matters, the application and the business logic. So now let's dive a bit more into the technical details and see what this really means and what it looks like. But first, we'll have a look at some really wonderful drone footage of the factory. Nice. Okay. So let's do some tech stuff, expand into some interesting details. We deal with manufacturing equipment. That's where we collect our data. It's not typically from web or from e-commerce. So that means we often interact with some systems, or control systems, or a PLC, for example, so programmable logic controller. And these devices are not designed to communicate over the internet. They are specialized for controlling mechanical equipment. So if we start on the left here, you have a representation of a system that we talk to, a PLC in this case, and then some IoT gateways. And these gateways are physical edge computing devices on the factory floor, which run our own operating system, which is a Linux distribution based on Yocto. And then on this device, we run a piece of software that we call a mapper. And this acts as an abstraction layer on the floor, which means that we can reduce the complexity in the cloud because we can generalize a little bit already on the factory floor, so to make it easier in cloud. We communicate with these systems and devices through a series of supported protocols. When it's a PLC, it's often OPC UA, but it can also be HTTP REST, or it can be SQL, or something else. That's all well and good, but the data is still stuck on the floor. These machines don't run in the cloud, right? Physically on the floor. So to be able to connect the system with our cloud environment, we need to establish a secure and authenticated connection. So let's do that. We connect and authenticate using IoT Core for certificates, and then we can start streaming data into Kinesis Data Stream as our entry point. Now, these IoT gateways are actually running on K3s, and that's a lightweight Kubernetes distribution specifically designed for these IoT production workloads. And then those are the worker nodes on the factory floor. The control plane runs in cloud. Then we release our software as highly available pods that come in pairs for this mapper software. And overall, as we build out the full factory, we'll expect thousands of these gateways, so thousands of nodes. And these nodes can be, as a concept, quite similar, but the hardware can be adapted to what we need as long as they can support this operating system. So that means sometimes it's a small device. You can think of it as a Raspberry Pi, but an industrial version of that. And sometimes it's quite capable machines with onboard GPUs to run machine learning workload and inference on large volumes of image data, for example. Now we have basically a fleet of devices that we manage. That already is an interesting use case and activity. And to manage the software, to do deployments, do the operations, do the updates, we need to have some part here that's highly reusable, so we don't start from scratch on every single device, of course. But we also need to support customization and configurability. So we achieve this with one main repository that shares the core, and we add upon that some customization where we can tag a release. So when we push this code, we review it, we merge it, and then Rancher Fleet picks up these tags and deploys the correct Helm charts to spin up the pods in the right location. So that means that the right nodes pick up these pods and start communicating with the assigned manufacturing equipment. Now, so let's start looking at some data flowing into the cloud environment. We start with a straightforward use case of monitoring, looking at some raw sensor data. The data model here is quite straightforward. So we have some source, some tag of what this is. We have a value, we have a timestamp. And this is also the kind of data that comes in the largest numbers and volumes. And we have a few use cases for this kind of data flow. First, of course, near real-time alerts are values out of the expected range, and we can throw up alerts. We can support decisions in near real time. We also want to do analytics or longer-term investigations, something that happened maybe years ago when we want to look at a long time span where we retain the high-resolution data. And finally, we want to do contextual joins. So maybe something happened, there was an event or a long-running process, and we want to attribute some time series also to what happened there. It can be to a process that ended or a specific product. And especially if we want to look at something in the environment and connect it back to the traceability of a product. As an example here, we have the mid-row that supports the near real-time workflow. So a hot path with Kinesis, Lambda, RDS, Postgres, and we can visualize an act, for example, using Grafana, but it can also be time series analytics tooling specifically for industry or manufacturing. For the long-term use cases, and where we need to store data for a long time and in large volumes and high resolution, we repartition this data and repack it as Parquet files and store on S3. So this allows us to access it with Athena or some other query engine, and still keep data for a long time in a cost-effective way. And finally, to do these contextual joins, we can access the data through Redshift and join with the contextual data that we have there. So this is good. This is already quite powerful. Still, it's a read-only workflow, which limits what we can achieve. So let's move on to some more exciting stuff here. So also running in our cloud environment is the software running the critical operations on the manufacturing line. What does that mean? Well, it does not mean that we run robotics control. That is probably not advisable. But it does mean that we make critical decisions in the cloud. So this is the MES functionality and capability that you would expect. So we're in a manufacturing track. We have quite a few people from manufacturing, I assume here. I'm going to use some concepts. Who's aware of MES systems? Familiar? ERP? PLM? Oh, nice. More than half the room. So we'll go through how this fits together. This is important because this now is not an optional retrofit. This is the digital backbone of the factory. This is how we run the factory. And you will see how the different systems connect from outside of this core integration framework, and everything comes together in that software. So let's start at the bottom right with the ERP and PLM. So ERP being the enterprise resource planning that takes care of company assets like cash and inventory and transactions, quite important stuff. This way we have sales orders, production orders, and so on. Then PLM, product lifecycle management. That's where we have the product and process definitions and also the source of truth for how we determine quality. Okay, and this is important that we put this in the center with the MES capabilities in the AWS box you see here, because having control of the integration on the factory floor and building ourselves this box that you see here, that means that we can choose the integrations we do with other software or system suppliers that come as leaf nodes on the system. So we keep control over the critical backbone here. And let's have a look and consider here how this all fits together in a use case as we move through the operations. So for example, in the ERP, we have a production order and we need to execute on it. So it's fed into the AWS environment here and being activated. Now we start producing. In the production order, we'll have information about what to produce and how many. And when I say what, there could be the part number or the model of the product, in our case, a battery cell. So if we follow a cell now, going through each process step, it might come into the assembly area, and we do a welding operation or an X-ray operation or something else is going on. And we collect data from these systems in the manufacturing equipment, and it's uploaded straight away in the Kinesis data streams. Then, because we hold the state in DynamoDB, we get this measurement data. We know what is being produced. We know from which process this data comes. So we can go to PLM and ask, what are the control limits? What are the quality parameters and tolerances that we need to abide by? And then we can go through the list of all of those and verify that everything is as it should be. And all of this happens serverless in DynamoDB, Kinesis, and Lambda. And if something should not go according to plan, not that it wouldn't, but hypothetically, that we have a problem somewhere, we will raise a nonconformity alert. And this becomes part of the traceability document. Now, this is moved to the quality team, and they have the mandate to make a decision. Do we accept this for some reason? Was the measurement wrong? Or they make a decision in the end to reject or accept. They do that using one of our applications that we built. There's the top right here, the web app for desktop and also for a mobile device. And that communicates with our backend through the GraphQL API. So now we save that state, we save that decision, and if this product should move into the next phase, let's say it was rejected, and it moves into the next process step. Now the next machine will scan in that cell and ask the state in the cloud environment, is this okay to proceed? And if it gets a no, then you pause operations. And this question is here represented by the API gateway workflow. And capturing all of this, every interruption, every quality deviation, every nonconformity in near real time, making that available to the operations team on the floor, and then aggregated for analytics later on, means that we can take action quickly and be informed and make prioritization later on as well. Now, let's move into some data stuff. Data in itself is a strategic component of Northvolt. It starts with traceability. And that is the ability to track exactly what has happened to each and every cell throughout each and every manufacturing process. Now, as we gather this data, we also create these high-resolution data sets across not only the cell manufacturing, but pack manufacturing and our R&D labs and validation equipment to create a unique asset to further optimize operations, but also make better products. Each factory here will have thousands of gateway nodes, ingesting hundreds of thousands of messages every second. So to run analytics on this, especially considering we'll have multiple factories, we need a flexible and scalable data platform so that we can do the monitoring we want, the analytics, the data science, and machine learning. If you look at the center row here, we capture the contextual data, what we get from, for example, from the applications, but also the raw data from the manufacturing line, with or without a human in the loop. This can be immutable data, such as events, but it can also be mutable objects, like identities or states. So every write to DynamoDB is ingested in, or it's captured by change data capture for DynamoDB streams. And then these hundreds and hundreds of data sets are filtered and joined so that we can design these analytics-enabling data sets. These data sets are then used by technicians and engineers and managers to prioritize initiatives, but also to root cause something that has happened. We rely here on a batch ELT paradigm for that central row, which means that we extract into S3 load into Redshift, and then transform the data using dbt, orchestrated here using Airflow. Now, at the bottom row, we have examples of the electrical measurements. So this can be laboratories and validation equipment where we discharge and charge batteries hundreds and hundreds of times to find out how they perform in terms of power, but also longevity. This is really useful for product development and validation and R&D. And what we have added since last year, when we talked about this, is another Kinesis data stream after the change data capture. And the reason for that is so that we can add the Kinesis data analytics, or the managed Flink offering. That means that we can nominate some really high-value metrics that we want to know in near real time, but are a bit complex to calculate. In our case, it can be mutable data that updates over time that also needs to be joined across data sets. So we have multiple streaming data sets that we want to join together and update as new information comes in. And then finally, not pictured here, but still really interesting from a data perspective, is computer vision workloads. So for example, taking images from the manufacturing line, doing distributed training on multiple cloud GPUs, deploying the best performing models to find defects using computer vision on the manufacturing line. And this again is using the same concept with the K3s cluster where we have nodes with onboard GPUs. Okay, so now we have covered a few capabilities and features inside one factory. Where this really becomes extra interesting to the next level is how do we scale this out to multiple factories? To do that, we have established a concept called Cloud Factory Modules. And it starts off with the physical layout of the site. So we start by looking at what buildings do we have on our site, and we create a dedicated AWS account for each building. And we then spin up a cluster for each of one of those buildings with the associated Kinesis data streams for data ingest. This is really nice because if you have an incident, it manifests somehow in the physical building, something is wrong there. And that maps directly, very transparently to our cloud infrastructure. In the core account, we deploy a number of services that are shared between the different buildings. So this can be, for example, DynamoDB for the transactions and operations. It can be RDS databases. It can be EKS for long-running processes also in the cloud. It can be OpenSearch or S3 buckets with raw data. In the data account, here's where we do the refining. So we take the raw data from the core account and start filtering, mapping, and enhancing, for example, with other reference data to create these data sets specifically designed for analytics. And this is, again, what we saw before with Redshift and dbt and Airflow. You can think of this as a DAG, essentially, a directed acyclic graph, where everything is replayable. So if we need to change the definition, or if we need to backfill data from the raw data, once some logic changes, that's no problem. And in this account is also where we deploy all of the workloads and infrastructure that we need for machine learning operations, or MLOps. Okay, so that's all we need. That's factory specific. We also need a few things that help us in the entire ecosystem or across factories. We'll start here with the shared account, and it offers the functionality for our developers. So for example, here's where we store secrets, Elastic Container Registry for images, and also our observability platform. So that includes Prometheus and OpenSearch and Grafana. we also have the network account. And this is really our network backbone. You can think of it as a big cloud router. We have transit gateways, direct connect, and firewalls in this account. And this account also controls the incoming and outgoing communication and traffic between our AWS accounts. This is also where we integrate with other cloud providers. So it turns out that multi-cloud is a thing, and in this account is where we face that challenge boldly and deal with the reality. But let's move on quickly from there. So finally, we have the global account. This is, for example, where we have the central GraphQL endpoint to provide a consistent front-end and UX experience connecting, for example, the mobile application. This traffic is then federated out to the right site with a federated backend. And this then opens the door to do access control based on location and role. And that, all of those things is what we need for one factory. And as you can see, when we go to the second factory and the nth factory, we basically spin up a new core account, we spin up a new data account, and for each building, we create a new building account. And this is really neat because now we can have one consistent framework, one architectural concept. We can move between sites and feel right at home, but still we have this customization potential and we can configure based on the site. So that's really the strength of this concept. Our vision with software-defined factories is using this modular framework of high reusability, yet local configurability. That means we want everything to be defined in code so that it's repeatable, it's consistent, it's portable, and it's evolvable. So we're taking the approach of everything is code and applying that to our factories. So that means factory as code. Everything we touched upon here in terms of data and software really is a great idea for a single domain or for a single factory. So that if you have a single factory, you still want to improve your operational excellence. You want to run data-driven workloads like predictive maintenance and predictive quality. And our bet is that the truly differentiating story lies beyond the single domain. It's connecting the links in the value chain. So in our case, it's the active material, this battery chemical that we design and manufacture. It's the cell manufacturing, the pack manufacturing. It's tracking and following the product during its operational life, and then finally doing the recycling. I say finally, but that's just the start of going back to the active material manufacturing. So what could be achieved here if we combine the data from all of the links in the battery materials lifecycle? For example, taking the detailed cell traceability from the cell manufacturing and combining that with the telemetry from battery packs that are storing energy on the grid. Or what could we do with the cell performance, this charging, discharging data from a validation lab, and combining that with simulations of molecular or chemical simulations of new chemicals or a new process. So time will tell, and we cannot wait. Today, we are 5,000 people at Northvolt working tirelessly to ramp up the first factory in the north of Sweden, which will be the first homegrown European gigafactory. It's early days still, and we have many more factories to go. Remember, the world needs more than 100 factories of this gigascale. These factories need to be green, they should be software defined, and we believe they should run in the cloud. 2 months ago, in the end of September, we also announced that we'll be expanding our gigafactory portfolio to North America. So we will set up shop in the province of Quebec in Canada, a fully integrated factory with active material manufacturing, cell manufacturing, and recycling. So there's a lot to be excited about. I'm really happy that you stayed with me the entire session here to listen to our story. I'm looking forward to speaking with you and have fun and interesting conversations. We'll take questions just outside the door here later on, me and the team. So do speak to us and work with us as partners or new team members. I want to thank you again for being here. Thank you, Kartik, for presenting with me today, and I wish you a fantastic day.